In this lecture, we're just going to introduce some ideas behind graphs and some of the concepts that we're going to use through the class. This is just to get everybody on the same page. A graph is going to be equal to a set of nodes and edges. Our set of nodes will be V, and our set of edges will be E. Here we have an example graph. We have our set of nodes. It's 1, 2, 3, and 4, and we have a set of edges. We can see that our edges are actually pairs of nodes. Any pair of nodes is going to define an edge. In general, this is how we'll describe a graph. We'll label the nodes, and the edges are going to be pairs of nodes. Occasionally, we'll label the edges explicitly too. Given a graph, we're going to talk a lot about paths. And a path is a sequence of nodes and edges that are adjacent. So, for example, in this graph, there's many paths. We're going to look for a path between 1 and 5. One potential path starts at node 1, goes across edge A to node 2, goes from node 2 across edge C to node 4, and then from node 4 goes across edge E to 5. The way we're going to describe this path is the sequence of vertices and edges that it goes through. So the path from 1 to 5 is 1, A, 2, C, 4, E, and 5. And this is a path from node 1 to 5. Another way to describe this path is as only the edges. And in this case, our path can be described as A, C, E. And this is a path from 1 to 5. Similarly, we could talk about only the vertices. This is a little bit more unusual though. Paths define connected graphs. A connected graph is any graph where there's a path between all pairs of nodes. So for example, this graph with 3 nodes and 2 edges is connected. Whereas this graph with 5 edges and with 5 nodes and 3 edges is not connected because there's no path from this node to this node, for example. Aside from paths and connected graphs, we're also going to be looking at subgraphs. A subgraph, in this case denoted by G prime, is any graph defined by nodes of V prime and edges E prime, is going to be a subgraph of some other graph, G, with nodes V and edges E. If V prime, the set of nodes in our subgraph, is a subset of the nodes in the bigger graph, and E prime, the edges in our larger graph, in our subgraph, is a subset of the edges in our larger graph. So for example, if this is our graph G, we can take a subgraph of it. And our subgraph we'll label in blue. We'll say take these 3 nodes, and let's suppose we take only these 2 edges. This yields a subgraph. And this subgraph, we'll draw in blue, has a node set that's a subset of G, and an edge set that's a subset of the edges of G. This is our subgraph G prime. We'll also be interested in cliques. A clique is a graph with all possible edges. A clique is sometimes called a complete graph. So for example, here we have a graph with 4 nodes. And we see that every possible edge is drawn inside of this graph. Conversely, over here, we have the same number of edges, or the same number of nodes, the same 4 nodes, but some of the edges are missing. For example, this edge between these 2 nodes doesn't exist, and so this can't possibly be a clique or a complete graph. Finally, in addition to graphs, subgraphs, and cliques, we're going to be interested in dual graphs. Dual graphs are very important for defining complementary problems. If we have a graph G equal to VE, to take the dual of it, we find a new graph, G prime, equal to V prime E prime. The node sets between these 2 graphs, G and G prime, are going to be the same. That is, V is equal to V prime. But the edge sets are going to be complements That is, anytime we see an edge E in E, then that edge is not going to be part of the dual graph, E prime. So if this is our graph down here, G, to take the dual of it, we take the same set of nodes, the same 4 nodes. But now every time we see an edge, we don't put an edge, and every time we don't see an edge, we do put an edge. In this case, there's only 2 edges missing from G, so our dual graph, G prime, has the 2 crossing edges. If we take the dual of the dual graph, we go back to the original graph. So taking the dual is an operation that gets us back to our original graph. Dual graphs will be important when we define complementary problems later on. This summarizes what we're going to need to know about graphs. We'll introduce things as we need them later on.